Hey everybody, so today we are going to be talking about lesson 10. This is going to be sort of an extension and more specific task, and it's related to lesson 9. You did some nomenclature of polyatomic ions. So again, a reminder, polyatomic ions are going to be these types of anions usually. There are two cations, but here we're going to be dealing with anions that have multiple types of atoms in them. So whenever you see a metal and then the second part of the name does not end in "ide," like IDE. For example, here it's nitrate. We know that that's going to be a polyatomic ion. So what we're going to do is, if it's nitride, it's going to be a sodium and sodium and nitrogen. Like that's it. But nitrate means that it's a polyatomic ion. So I want to go through all of the examples so you can see my thinking going through each of the steps. And then I want to show you how to go from scratch using just the names for certain examples. So here, sodium nitrate. So first we need to write out the charges separately. So sodium, if we go to our periodic table, it's going to be Na. It's in the first group, meaning it's just going to have a +1 charge. So I'm going to write that Na plus. And then our second one is going to be nitrate. So we're going to go to our, let's see if I can find it. Oops. How about I pull this up? Going into lesson 10, you're going to find the list of common polyatomic ions here. So nitrate. So if we go down here, we're going to find nitrate. It's NO3 with a single minus. So NO3. Again, for the superscripts, I'm typing command right arrow, and then for the subscripts, I'm typing left arrow, and then NO3 minus. Sorry, the charges aren't like right over it, but that's how I'm going to write it. And then do the charges cancel out? Here, in this case, yes, they do. And then we're going to write the chemical formula. Because these charges cancel out, we don't need to do anything in terms of switching, crisscrossing subscripts, but we need to also include this 3, because NO3, this thing right here, that's one ion. You need all of the atoms and subscripts. Whenever you are working with a polyatomic ion, pretend like this is a single atom, right? This whole thing has a minus charge, therefore this whole thing will cancel out this positive charge. So I'm typing NaNO3, and that is going to be our completed formula. All right, so sodium chlorate. We know that sodium has a plus charge. And then chlorate, let's go find that. Sodium chlorate. So we're going to find chlorate, ClO3 minus. So ClO3 minus. Do the charges cancel out? The answer is yes, they do cancel out because it's just a plus and a minus. And then we're just going to type this whole thing out because this is one-to-one ratio is going to cancel out the charges. So NaCl, O, and then 3. There we go. That is a neutral ionic compound. Lastly, magnesium nitrate. So now we are dealing with a new type of metal. Let's go to our periodic table. We're going to find magnesium in the alkaline earth metals. So that means it's going to be a +2 cation. So Mg 2 plus. Oops. And then the other charge, nitrate. Nitrate is up here, so we know that's going to be an NO3 minus. Oops. So here the charges do not cancel out. So what we're going to do is the crisscross method. Now, when you do the crisscross method, it's getting a little tricky because we are dealing with both superscripts and subscripts. What you're going to do is crisscross the charges only, okay? So what that means is that the 2 charge goes to the NO3, and then this only has a negative charge, so the 1 comes down here. We don't write the 1 after the magnesium. So let me show you how I'm going to do this, because we need to have 2 nitrate ions in total. Whenever we're showing we have multiple polyatomic ions in a chemical formula, we put parentheses around that polyatomic ion. So Mg, there's only one magnesium because the 2 plus is canceled out by the 2 nitrates. So I'm going to put parentheses NO3, and then I'm going to end the parentheses, and then I'm going to put a 2. So what this 2 means is that we have 2 of these things. That's why the parentheses are really important, because if we put the 2 after the 3 without a parentheses, that's implying we have 32 oxygens. We do not have 32 oxygens. We need to say we're having 2 of these nitrate polyatomic ions. That way, these 2 negative charges cancels out the 2 positive charges from magnesium. All right, let's do a couple examples. I want to go through number 2, number 3, and number 8. So number 2, we have lithium phosphates. So lithium, if we go to our periodic table, lithium is going to be in the alkali metals. That means it's going to be forming a +1 cation. So lithium phosphate. Now it's not phosphide, so we know it's going to be a polyatomic ion. So let's check out phosphate. Phosphate is PO PO4 with a -3 charge. We know lithium forms a +1 charge. So to cancel out the -3 charge from the single phosphate, we need 3 lithiums. And if you write out the charges separately, you're going to see that the crisscross method is necessary, and that 3 from the phosphate is going to go right after the lithium. So Li, 3, and then phosphate, we just type out the entire formula, PO4. So Li3, PO4. There we go. -3 charge cancels out the 3 plus charges. All right, let's do number 3. Magnesium acetate. So we know our magnesium is going to be a 2 plus from above, right? And then acetate, we need to figure out what that polyatomic ion is. So if we go here, acetate is this longer compound, CH3COO, with a single minus. So magnesium is going to have a 2 plus, and then acetate is going to have a 1 minus. That means, applying the crisscross method, we need 2 acetates to cancel out the 2 plus from the magnesium. So I'm going to type in magnesium, and then I'm going to enter parentheses because we need 2 of these acetate polyatomic ions. So CH3COO, and then I'm going to add a 2 after the parentheses saying, hey, there's 2 of these acetates. That means there's 2 negative charges canceling out the 2 positive charges from the single magnesium cation. Lastly, let's go to number 8. So number 8 is going to be copper to permanganate. All right, so we know that this copper, it can form multiple types of cations, but in this case, it's going to form a +2 cation because this Roman numeral 2 is saying, hey, this copper is a +2, and then we need to figure out what permanganate is, what kind of polyatomic ion it is. So let's go to our polyatomic ions. Permanganate, I see it down here, copper to permanganate. So what that means for us, this forms a -1 charge. That means if copper has +2, we are going to need 2 permanganate ions to cancel out that +2 from copper. So it's going to be similar to number 3. So copper, and then permanganate. So MnO4. And then we are going to add a subscript 2 after those parentheses to make sure we're saying, hey, there's 2 permanganates canceling out the 2 plus charges from the copper. Now make sure you are being really specific with your parentheses. Parentheses should only go around polyatomic ions because we're signaling that all of these atoms are part of one ion. They're one entity. Think of it. Like, imagine this is just one type of atom, and we're saying there's 2 of them. Same with this. They're one type of ion, except they're made up of multiple atoms. Chemistry is pretty cool like that. You can put together a bunch of atoms and still have like a negative charge that you can treat as one thing. So give this a shot. Let me know how it's going for you. Send me an email if you are getting confused, but that should be pretty thorough in terms of an explanation of how to do this process of writing the chemical formulas for polyatomic ions.